This conference will now be recorded.
Yes, we are recording. Be watched again. So we're also going to encourage you guys to use the chat box if you've got questions that you want to ask any of the presenters today. You can type it in. Like we've done in the past, we've extended the webinar to 30 minutes past the hour to accommodate for any questions. We've got it if we need it. Most of the speakers are probably going to speak for their full 15 minutes, so get your questions ready. But with that, we'll like to talk about who's going to be presenting today. That would be the next slide. There we go. So we've got Whitney and Andrea going to be talking about after the flush, and I had so much fun with that tool topic coming up with. Well, anyway. We've also got Carl, actually Grant is going to be talking to us today about the Extract Imagery Analysis Tool, and Brian is from BOEM is going to be talking to us about some of the sediments in their marine minerals information system. But before we get started with that, we're going to have a word from our sponsor. And it's Keith. Will be talking to us today real quick about some applications and databases they have at Esri that are comparable to what our theme is for this week. So with that, I'm going to pause my camera and let Keith take over.
Thanks, Dave. Thank you, everyone, for participating in the GOMA webinar series. And we're excited to talk today about marine spatial planning. My name is Keith Van Graafland, and I am a product engineer at Esri. I specifically focus on ocean content for a long-term project that we have that provides content to our community, from our community, is the Living Atlas of the World. And I'm also joined here by a colleague of mine, Dr. Lorraine Tai. She's the Director of Earth Science Solutions, and really the reason we're able to sponsor this event. So big thanks to Lorraine and her continuing support for these GOMA webinars. Before we dive into just a tool and work we've been doing in the marine spatial planning space, I would like to invite everyone to our Esri Ocean Weather and Climate GIS Forum. That's occurring next month, about a month from now. It's virtual, and it's also complimentary. So we're going to have 2 days of presentations, both from the community and from Esri, highlighting technical capabilities within the ocean, weather and climate space, and how our technology can be used to, adapt to the changes that we're all up against and support science. So if you haven't done so already, please visit our ocean weather and climate website, register. All it takes is an ArcGIS Online login, and consider joining us. We also have abstract submissions that are open until the 8th, which is Thursday. And with all these presentations that are going on in the GOMA webinar series, please consider also presenting your interesting work in your work for the community at the event here in November. With that, I'm going to transition over to some work that I've been involved with recently, and this is focused around AIS data, automatic information systems for vessels tracking within the United States. So we're all probably, or most of us are probably aware that the U.S. Coast Guard, BOEM, and NOAA make AIS vessel traffic data available through the Marine Cadastre site. And traditionally, this data is delivered as a bulk of CSV files that really take a lot of rigor in order to work into something that marine spatial planning audience or practitioners can use to understand the patterns that are occurring not only spatially but temporally within the waters of the United States. And recently we've been working on some data products to help make available this data to our community in a more readily available and analysis ready fashion. So what we're looking at here is just a prototype application that we put together for the annual 2017 AIS data. So up until early this year, I say early, probably May this year, 2017 was the last released AIS data that was out on the Marine Cadastre site. And AIS data is really like census data for the ocean. We were able to understand the different types of vessels that occupy different spaces at different times, and consequently we can identify space use conflicts. So here we've worked up the 2017 AIS data, and we've got it available in a time slider using vector tiles, and currently we're looking at just fishing vessels off the coast of Washington. So this is available for the whole United States. You can pan around and understand not only what's going on in the fishing perspective, but you can also look at the different shipping phenomena and other type of vessel groups that are occupying different locations over different months of the year. So this information is really useful because you can really understand exactly where these patterns are occurring. And here we're looking at traffic separation scheme between US and Canada going through the Strait of Juan de Fuca, and where those different cargo vessels go into to unload. And then here you can even see the granular locations where they've docked and they've anchored, and you can see here by the circular nature of these patterns that they've anchored for a period of time and been able to make it through a couple tide cycles where you can see that circular pattern from the incoming and outgoing tide and their anchors kind of holding them in place and them drifting around their anchor. You can also look at the different passenger systems. So Seattle really has a fantastic passenger ferry system to help people get across the water on their daily commute and see the different docks that are being used for the transportation of persons across the water to let them get to their daily jobs. So bear in mind, we're just looking at 1 month. This is January of 2017, and we're able to understand, what the passenger system and network looks like in these locations. Not a lot of passenger network outside of the sound system, but once you look at the tanker system, you can see where the tanker system starts and where that ends. So this is really a kind of a newer way to work with vector tiles and AIS data to have a very good performing visualization of AIS data and how these different vessel groups interact with each other and support each other in a lot of cases where tow vessels take over for cargo ships and whatnot. Here you can even see how far upriver a lot of these different towboats make way. So I encourage you to check out this application. I'll put a link to it in the chat window, but we're working on making these layers as well as analytical layers to support this data available in the Living Atlas later this year and the beginning of next year. and want to marine spatial planners to have, reliable information that's prepared in a timely fashion to support their marine spatial planning needs. Sometimes working up this data takes longer than what the scope of your project might allow. Along those lines, we're also going to be offering an image service where you can understand this data and the multidimensional aspects of it. So here, we're looking at the same data set gridded to 1 kilometer resolution, and you can look at the different variables. So here is the month of April for fishing, but you can easily switch over to cargo, understand what cargo looks like, and let's say you want to get a temporal profile for a pixel and see what a specific location has as far as over time, the amount of cargo vessels. You can easily place a point on a map and understand here that January at this 1 kilometer by 1 kilometer cell far exceeded the cargo density of the other months. Why that is, I'm not sure, but there is some sort of pattern that was really exceeded in the month of January here, that dropped off in February and seemed to pick back up in March and continue on throughout the year. So with that, I'm anxious to learn more about these marine spatial planning projects that you folks are going to discuss today. Encourage you to reach out to me with any of your questions about AIS data or anything Esri related. And thanks for letting us participate in this great webinar series.
All right, well, thanks, Keith. I appreciate it. If you could put the link in the chat box to the Ocean Forum, I think that was one of the requests. I'm dropping in the link in the chat box today, right now, for the agenda. And in that agenda, there's a link that Christina shared, that Keith was just showing us about, and it's got descriptions for the rest of the presenters. So we're going to dive right in, and I'm excited to hear from Whitney and Andrea about after the flush. So I'm ready, and it's off to you guys.
Thank you, Dave. Hi, everyone. Here, let me undo my camera or share my video as well. I am Andrea Alberton, and I'm the Regional Water Resources Agent in the Florida Panhandle. And I'll be doing a brief introduction as to why, in Extension, we feel that there's a need for this after the flush homeowner septic system program. But then Whitney Elmore, our Pasco County Extension Director and Horticulture Agent, is really going to lead the presentation and get into the nitty-gritty of the tools and the resources that we have available. Next. So why is there a need for a septic system education program through Extension? I'll get into a little more detail on these topics in my next slides, but basically we have a lot of systems in Florida. They are a known source of nitrate to groundwater and surficial water, coastal water as well. We have adopted new regulations in the state that directly affect residents with these on-site wastewater treatment systems, or OSTDS. Conventional septic systems are a type of OSTDS, so I'll interchangeably use those septics and OSTDS. And then also, it's a really contentious issue in Florida. It impacts residents and it impacts their wallets. Next, please. So how prevalent are these OSTDS, these septic systems in Florida? So we have, conservatively, the Department of Health estimates that we have about 2.6 million systems in the state. And this translates to over 30% of the population relying on them in Florida, which is over 7 million people. The Department of Health also estimates that septic systems discharge more than 400 million gallons of treated wastewater per day. And what I've shown here on the right is a map that DOH, they have a phenomenal program. It's a project called the Florida Water Management Inventory Project. If you look up this website, actually, this is an interactive map talking about tools, but in green, what they've mapped out are known septic or likely septic land parcels, and you'll see that sewer and likely sewer are in yellow and brown. So if you go into this website and click on a county name, you can actually get a very good resolution close-up of the parcels connected to sewer or septics in each county. And you'll see that we have septics throughout the entire state, and that sewer is really concentrated in our more highly populated areas, which is our coastal cities, and of course Orlando and Jacksonville. Next, please. So septic systems really were never designed to reduce nutrient inputs to groundwater. So basically they were designed, of course, from a public health perspective, and they don't do a good job of removing nutrients. It's estimated that a conventional system removes only about 30% of the nitrogen that goes in. So again, another estimate, we produce about 9 pounds per person per year of nitrogen in sewage, and of that, about 6 pounds per person per year is released in the effluent. Next, please. So about our regulations, in 2016, Florida passed our water bill, so it's relatively new. And this created the Florida Springs and Aquifer Protection Act. What this act did in turn was create a whole new category of protected waters in the state, which are our outstanding Florida springs. We have about 30 of these historic first magnitude springs, and that means that their discharge is on average 100 cubic feet per second or greater. 24 of these outstanding Florida springs are identified as nitrogen impaired. And so TMDLs have been set for all of them, and basin management action plans, or our famous BMAPs, have been developed and approved for 13 of these spring systems. And what a BMAP is really a roadmap of action items that have to be put into place in the springs discharge, the springs recharge basin. So it's action items put into place in the springs recharge basin to really get that TMDL down to the new levels that have been set. And these springs recharge basins can vary in size. Some are hundreds of kilometers squared, others are thousands of kilometers squared, depending on which spring system you're in. Next, please. So finally, what the state does that in each of these springs recharge basins, it identifies the source contributions of nitrogen and what percent, an estimate of what percent they contribute to the water coming out of the spring system. So I have an example here, a pie chart for Wakulla Springs here in the Tallahassee area where I live, where the state has identified that septic systems contribute 34% of the nitrogen load that comes out of the spring boil that's discharged. So if within an impaired spring system, more than 20% of your load is estimated to be coming from septic systems, a septic systems remediation plan has to be put into place. Now, what does this septic systems remediation plan look like? Basically, within the springs recharge basin, a priority focus area is established. So that is an area where the land use is more likely to impact the water quality coming out of the spring. And this is usually due to geology and proximity to the spring head. So in this area, no new homes can be built with conventional septic systems. They all have to be built with advanced nitrogen reducing technologies. No new permits are issued to fix septic systems. So for residents in these priority focus areas, if their septic systems fail, they also have to they have to get these new advanced treatment systems, which can be very, very expensive. And that's where a lot of the contentious issues are coming up, because it's just, we're all trying to figure out how to help residents pay for these in case they have to switch over to these advanced treatment systems. So again, that was really just an overview of why we are creating this toolbox, and I'll let Whitney take it away and go through that resource.
Thanks, Andrea, and thanks for having us with you this afternoon. I do feel a little underdressed compared to Dave in his hard hat earlier, but thanks for having us. Obviously, we have some pretty big issues when it comes to water in Florida that most of you are very familiar with. From the septic side of things, this is overall a pretty new concept in terms of trying to create behavior change, not only to extension agents, but certainly to the general population. So we were finding, number one, that extension agents needed literally a toolbox to package all of this information, because some of it's coming from DEP, some of it's coming from Department of Health. It's coming from many different angles, and it really needed to be packaged in a way that, one, extension agents could be able to use the information to educate the community and be headed in the direction of behavior change, but also to help educate the public. It has become a contentious issue, like Andrea mentioned. It is a costly transition for folks, but this is a serious situation that we're talking about with these nutrient loads and trying to reduce them across the state, especially when you look at the dependency that we have across the entire state on the septic systems, the conventional systems. So we wanted to put together basically a toolbox, a practical toolkit, if you will, that supplied information about regulations on septic systems and provided the legislative updates all in one place. Information that would explain what a BMAP is and help people determine if they even lived in a BMAP. Most people are not familiar with that, and how to determine if they're in a BMAP, and especially a priority focus area. We also then developed a series, and we're still developing a series of fact sheets on simply how septic systems work, maintenance, best management practices, even things for landscaping around drain fields. There's a lot of confusion in that area. The environmental impact of septic systems, and then what are advanced septic system options, and how might those come into play for folks that find themselves in a priority focus area and either installing new or looking to replace. We have put together a series of public service announcements, videos about how septic system works, just overall maintenance, repair, and replacement into this toolkit. Again, not only for extension agents, which it's more expanded for them. It provides the PowerPoint materials, the evaluation tools to be looking at not only knowledge gain, but definitely behavioral change down the road in the future. But then, information about advanced treatment options, and then especially the environmental overview and impact. And we are producing these in English and also creating Spanish versions as we go along to reach as wide of an audience as possible. And so this is the link to our toolbox, and we can share that with you a little bit later on, but I want to get into it and show you just a couple of things in the time that we have left. We've got just a tiny bit of lag in the, there we go, tiny bit of lag. But this is just kind of an introduction then to septic systems that you can see here as I scroll down. I'll try to go slow and not give you whiplash. But just the basic components. We were finding in a lot of the needs assessments that folks really don't even know if they're on a septic system, certainly how it actually works. And then if they might be in a BMAP or any of those kinds of things as well. So this is really just an introduction overall to septic systems. And here you can see where we've tried to logically link to fact sheets in some places. If it's going to load, it might. Here we go. All right, so this just gives you an idea here of, why do septic systems need maintenance? And so we worked with some graduate students, had them develop some of our illustrations for us, but we've tried to really lay out the groundwork of why this is important information and why it's so critical overall for folks to be using the toolbox at the same time to educate themselves. Let me go back over here. So we talk about lifespan of the septic system, the overall concerns that folks might have, and then signs of a failing system, which we found is people really just don't understand how the system works and then how to determine if it's failing. So you can find a variety of fact sheets throughout, and I want to bring your attention to the resources page of the website, useful links, Thinking before you flush. So Dave, you referred to after the flush. We did have a pretty good time putting this program and this toolkit together, because what does take place after the flush, that really what it is all about. You know, where do these nutrients go, and helping people understand that they are part of the problem, not just in how they're fertilizing their lawns or agricultural operations or commercial operations, but just their everyday activities in their home contributing to septic systems can be an issue. So we have linked to DOH, we've linked to Environmental Protection Agency, all kinds of organizations to package everything into one toolkit. And we also talk here about understanding the overall incentive program that is offered through Department of Health and DEP. And just to give you an idea of some of our videos, and again, we have these in English and Spanish versions as we start to finish up here. And hopefully you will find this
I'm going to
useful.
interrupt. I'm sorry. 2-minute warning.
Thank you.
Sorry.
Hopefully you'll find this interesting and helpful to you in whatever you're doing, being able to share. They are vital to our economy, our wildlife, our environment, and our people. All waterways are impacted by our everyday activities. There are small steps you can take to make them healthier and sustainable for generations to come. What happens after the flush? Where does wastewater go once it leaves your toilet? If your home has a septic tank, that tank is designed to be pumped every 3 to 5 years to avoid costly backups and environmental pollution, as the system drains into the surrounding soil, eventually finding its way into our waterways. Harmful bacteria, medications, and the nutrients in the waste are all problematic for our priceless water resources. Nutrients in the waste can even fuel toxic algal blooms. By pumping your system as recommended, properly disposing of medications, and being mindful of what's going down the sinks and drains, you can help protect and preserve our Florida water. So that just gives you a little bit of an overview of what we've got here, just to get people thinking about the, well, that's interesting. We don't have anything about Texas in there. Sorry about that. Something with YouTube. That was pretty good. It's kind of jazzy though, wasn't it? But this just gives you an idea, and we have frequently asked questions as well. And you know, why is nitrogen, excessive nitrogen, a concern? I really hope you'll take some time to kind of explore the toolkit and how you might be able to use it in your program areas, but also how you can get it over to the public. And again, we thank you for having us. Andrea, did you have any last comment there?
No, that was great. Thank you, Whitney.
Okay, thanks.
All right. Well, guys, thanks very much. And I'm going to encourage everybody to use the chat box if you've got questions for either Whitney or Andrea. But we're going to go jump right into the next presentation. Grant Wiseman is going to be talking to us about the Extract Imagery Analysis tool. So I'm going to turn it over to Grant. On your mark, set, go.
All right. Well, thanks so much. My name is Grant Wiseman. I'm located in Winnipeg, Canada, in the Great White North. I was contacted by Carl to get some talk today about some of the remote sensing specialties that we're doing at Stantec. I am the technical leader of something we're calling the Remote Sensing Center of Excellence. So I'm bringing you some services that are applicable to the Gulf of Mexico Alliance. At Stantec, safety is always top of mind. So with any meetings that we have or presentations, we always include a safety moment. Given the COVID-19 situation, a lot of us are currently working from our homes. So we have to be aware of carbon monoxide as we spend more time inside of our homes. It is a odorless, colorless gas that can creep up from the soil into your home. Be sure to have carbon monoxide detectors installed. Ensure they're operating correctly with their battery pack, and please do check them regularly. So wanted to kick off the talk about remote sensing and some of the benefits. So obviously there's going to be a cost savings when we're talking about acquiring imagery. We can cover vast amounts of land and landscape using satellite-based images. They provide a unique perspective. You can capture the entire length of your assets and project site instantaneously. We can use different forms of the electromagnetic wavelength. We can use near infrared, thermal infrared. We can use radar to interpret what's happening on the Earth's surface differently. And of course, remote sensing provides health and safety risk reduction. Anytime where you can keep people out of the field and you can do things from your desktop, you're going to be reducing health and safety risk. So as I mentioned before, this is the crux of the Remote Sensing Center of Excellence. We use all forms of electromagnetic energy, including LiDAR and bathymetry. We use multiple different platforms to collect that data, be it satellite imagery, which is my expertise, but we also used manned vehicles, planes, helicopters, unmanned aerial vehicles, drones, UAVs, and we also have a section for unmanned marine drones. So here's a list of services that we're currently providing. I'm going to talk about the first three in our discussion today: ExtractX, SUM, and our water quality products. There's also a variety of other different tools that we can provide, but we simply just don't have the time today. Happy to discuss these offline with you at a later time. So ExtractX, this is really our detailed mapping service. ExtractX is built off something called object-based image analysis. And it's essentially doing what the human brain does instantaneously. It breaks down the image into recognizable features. And it does this using color, texture, shape, and size. So it replaces what the old photo interpreters would do, taking them days or weeks to draw landscape features on top of the area photo. This can be done in seconds. It's quantifiable. Everything we do is statistically based, making it eliminating the human bias, making it scientifically repeatable and ideal for change detection analysis. So here's a typical scenario. Here we were up in Anchorage, Alaska. Our client wanted to map out the vegetation communities within a wetland. So we had some beautiful unmanned aerial vehicle imagery at 5-centimeter resolution. We had the RGB EM waves and the near infrared channels. And what we did was send out field crews with GPSs. They went out into the wetland and they were actually taking GPS points for each vegetation community type. Then I was able to take that imagery and run it through our ExtractX segmentation process. We're breaking the image down by color, texture, size, and shape. Then we're actually training the software. Okay, this is what an open black spruce looks like statistically based on color, texture, size, and shape. This is what a closed black spruce stand looks like. So once we're able to train the model or calibrate the model then goes through each of the remaining objects in the image and classifies them very quickly. Everything that we do, again, is in a GIS type environment, so we can very quickly and easily summarize statistics on those vegetation community types. Another example here, Lilu Island in Canada. Again, we had some beautiful drone imagery. Here, the client wanted to know the density of eelgrass, intertidal eelgrass on Lilu Island. So here's just a zoom up of the intertidal eelgrass in the imagery. Again, what we did, we sent out field crews with 1 meter by 1 meter quadrats, and they were actually calculating the eelgrass density in each of those quadrats. We used that to train the ExtractX model, and we were able to map out eelgrass density based on that field data. So we had 3 classes of dense, open, and sparse eelgrass. And that's just a zoomed out shot of Lilu Island. Of course, we can also do submerged aquatic vegetation. The image in the top left, that's your typical RGB signature. Pretty good, but we can certainly improve that. We use something called a coastal channel. It's a very, very short wavelength, so it penetrates the water column better to see seafloor vegetation. Again, we run our segmentation process in the bottom left, and then it's a presence absence classification of submerged vegetation in the bottom right. Okay, shifting gears entirely. We're going to talk about something called surface subsidence and uplift measurement. So we're actually measuring how much of the Earth's surface is either uplifting or subsiding. It uses something called interferometric synthetic aperture radar satellite data. And it's just a fancy way of saying that it's recording how much the Earth is moving on the vertical axis, looking for things called phase shift from one image to the next. And from some detailed calculations, we're able to, with millimeter accuracy, tell you how much that land surface has been moving on that vertical axis. Capable of a millimeter subsidence movement detection. In Stantec, we use a global archive of INSAR imagery dating back to 2015. So for any point on the Earth, we can tell you how much it's been uplifting or subsiding for the past 5 years. We always say it's a really great way to predict the future subsidence problem. There's really no better way to predict subsidence problems than by looking to the past, pardon me. And the beauty, again, of satellite imagery, we can do statewide coverages. We use a freely available satellite imagery archive. This is for an area in the Fraser Valley Delta in British Columbia. You can see the areas in red are subsiding at a rate of 5 millimeters per year. This is a coastal erosion project and sediment deposition project we did in Washington State, namely Willapa Bay. We took imagery from 2016 to 2019, and we're able to see how that coastline was eroding or where the sediment was building up from increased storm runoff events. This was having a detrimental effect on the oyster and burrowing shrimp industries in the Pacific Northwest. And again, any areas in blue, we're seeing sediment deposition in the intertidal areas, and any areas in red, we're seeing erosion. Same study, just a bit further south, or pardon me, north in Grace Harbor. Every pixel there is represented by a 20 meter by 20 meter grid. And again, on that vertical axis, we have millimeter accuracy and precision. This is another study we did for the California Department of Water and Power. Here, there were a number of factors in play, including groundwater, dewatering, and recharge. So you can see the areas in blue again, areas that are increasing, any areas in red were decreasing at about a rate of 2 centimeters per year. Moving on to water quality properties. So there's a number of different water quality properties that we can obtain using satellite imagery. Those are total suspended solids or turbidity. We can look at sea surface water temperature, dissolved organic matter, chlorophyll A. Really, satellite data is ideal for multi-temporal change detection. Here we're seeing the effects of construction upstream in the Bay of Fundy in Nova Scotia, dating back from 1987. We tracked the sediments, the TSS, I should say, from 1987 to 2012. Any areas in green, we're looking about 1 milligram per liter. Any areas in red were over 30 milligrams per liter. Sea surface temperature, we can get some very accurate readings up to a daily interval. Here's a shot of near Los Angeles, California. Any areas in red, about 22 degrees Celsius, just to the northwest, down to 12 degrees Celsius. This is a study done in my home province. The hydroelectric company basically cut a channel to get increased flow to their northern dams, and that had a detrimental effect to the organic matter in that lake. to the north, Play Green Lake, and we were able to track how the dissolved organic matter was changing the cyanobacterial blooms in that lake. This is a historical analysis dating back from 1974 to present day. And finally, water quality for chlorophyll A. There is a global historical archive dating back to the 80s. It's updated every 32, 8, or 4 days. We could do Gulf-wide trend analysis with this data or site-specific monitoring using this data set. So please, if you have any questions about any of these remote sensing technologies that you have seen, you're encouraged to reach out to either myself or Carl. Thank you so much for your time today.
Wow, Grant, man, that was awesome, because I was just getting ready to come in and give you a 2-minute warning. So, you timed that perfectly. So again, if you guys put your chats in the chat boxes, we'll have time to come back, or chats, put your questions in the chat boxes. We'll have time to come back to our presenters afterwards. But right now, let's go ahead and switch gears. Grant, thank you for yours. We're going to dive right into Brian. And Brian's going to talk to us today about some information and some tools that BOEM has to offer. Brian, you're on.
Everybody hear me?
Yep, you're good.
Yes. Great. Terrific. So I really like to appreciate, thank you everybody for, giving me an opportunity to talk today about the Marine Minerals Information System. My name is Brian Cameron, and I'm an environmental scientist with the Bureau of Ocean Energy Management's Marine Minerals Program in the Gulf of Mexico in New Orleans. So I'm a little bit further south than Winnipeg, a little bit further north than Pasco. I am, for those of you who don't know BOEM very well, we are a bureau within the Department of the Interior, and we're more often known in the Gulf of Mexico for our work with conventional energy resources on the intercontinental shelf. We do this in an economically and environmentally sound manner. We also have renewable energy programs, especially along the East Coast with offshore wind farms. But one of the big things that a lot of folks that really don't realize, it's a very small program within BOEM, and there's not a lot of people who work in this program, and that's the Marine Minerals Program. And we're the staff that manages the non-energy marine mineral resources. So your sand, your gravel, your rare earth minerals, those things that are very far offshore, as well as stuff that's used for restoration projects close to shore. And we do this to facilitate access, promote, responsible use, and minimize and avoid environmental impacts. To give you an idea, we've been doing this for quite a few years now. The program really kicked off a lot back around 2007, 2008, when it really started going close to full speed. Over the course of that time, we've helped restore 360 miles of beaches in 8 different states by providing sand and sediment. We've authorized nearly 165 million cubic yards of sand and sediment. To give you a perspective of what that means, you could fill up the New Orleans Superdome about 300 times with that amount of sand. So to get into what we're going to talk about today with the Marine Minerals Information System, the MMIS, as I'm going to call it, is an ongoing initiative that we started in 2014 with our state and federal partners to support the National Offshore Sand Inventory effort, as well as be an information resource for our partners to use. The MMIS tool is used, like I mentioned, to support the offshore sand inventory, and it also fosters access to the nation's offshore mineral resources. As you can see, it serves multiple purposes, from managing and storing data analysis, discovering sand and sediment resource areas, as well as identifying gaps in the data. And it gives an opportunity for partner agencies with many federal and state stakeholders, such as the partners you see on this slide. All the Gulf states are involved in this, as well as majority of the other federal agencies that have a role in offshore activities. While I'm going through these slides, feel free to access the tool at the website that I provide in the chat box. Play around with it some, and at the end of the slides, I'm going to go through and kind of give a little demonstration of some of the stuff that we're working with. So as I mentioned in the previous slide, BOEM works with our federal and state partners through cooperative and interagency agreements all along the nation's coastal zone. In addition, we funded over $50 million in studies to assist in the collection of data to be used in MMIS. And this ultimately leads to assistance for better planning for projects on the OCS, whether we're working with multiple use conflicts such as pipeline emplacement and decommissioning, state coastal restoration projects, siting for offshore wind turbines, or even potential aquaculture sites offshore. One of the most valuable assets of the MMIS is the housing of that national offshore sand inventory. Keep in mind that when this was first developed, mixed sediment was not widely requested, but it does include sediment as well. Over the years, we have had a lot of requests from the state of Louisiana for sediment that isn't just strictly composed of sand. And, we have that available on the Outer Continental Shelf in federal waters. So we do work with the state to identify that, as well as be able to make that accessible to them. The bulk of this data that is in the MMIS is located in the Gulf of Mexico, mainly due to the amount of storms that we get and the need for restoration and renourishment projects along the Gulf Coast. One of the cool products of this is that you can actually see what the core samples are, and you can actually go and select the layers for the core samples and access all the data that comes with it. Unfortunately, it's only for those that have been published publicly. We are working on trying to get as much information in terms of the attributes to be made available, but not all the samples have all that information in terms of the metadata available. But there's actually a core sample that I'm going to show y'all at the end of all this that is really neat to see, where you can go in, you can access it, and you can see all the different layers. You can see the write-up on the report, as well as the photographs of the individual core sections. The sand resources attributes are also a useful tool for BOEM as well as the stakeholders to be able to locate sand and sediment offshore that would be suitable for restoration projects. It's not just a matter of being able to go offshore and say, oh, we need 1.5 million cubic yards of, sand for our beach. It has to be a certain grain size. It has to be a certain percentage of sand, might have a certain percentage of carbonate that's in there. A lot of states have requirements in terms of what they will allow on their beaches. So being able to look at these resource areas and to be able to definitively know what's in that area is very important for us as well as for our stakeholders. Like I mentioned, BOEM works with our partners to set up a template for metadata to make it easier to meet the needs of our stakeholders. But all this is downloadable on our MMIS page. I'm going to show it to you in a little while, how you can download this information. If you'd like more information about the schema, the metadata, I'm not the person to ask. I'm an environmental scientist. We do have some people that are a lot more technologically inclined that can handle this more specifically. And, that's Laura Turner and Kirby Dobbs in our Sterling, Virginia office. So, I have no problem giving y'all their information, and y'all can reach out to them if you want to ask more questions with regards to the metadata and the schema. The slide right here is talking about the sediment resource evaluation. So this represents a great example of the products that come from our cooperative and interagency agreements related to the National Offshore Sand Inventory. You can see how identification of shoals for offshore borrow sites are identified, as well as data gaps that BOEM and our partners can work to fill at a later date. A perfect example would be the work that we're working on with the U.S. Army Corps of Engineers, where we use data from their sand study and previous geological and geophysical survey work from BOEM, as well as the state of Florida through the Rossi program, to identify data gaps for determining the location of offshore sand for future restoration and renourishment projects, as well as to be able to support the coastal storm risk management process that the Corps of Engineers is currently undertaking. Let's get to the next one there. There we go. Some other tools that have really been able to be applied through MMIS work, of course, is the analyzing sea turtle entrainment risk, also known as ASTER. That is a standardized geographic and temporal decision support tool that analyzes up to 21 biological and environmental parameters to inform entrainment risk. It also helps with identifying risk factors and data sources for tool development. And it's a good temporal and spatial tool to see what the sea turtle behavior is within and around the borrow area sites and try to avoid any takes to those sea turtles during activities. Another one that you're actually going to learn about next month in the Virtual Tools Cafe is Shoalmate. Dina Hansen, one of the biologists that works in our office, she's going to be discussing that, and that's a really great tool that gets into the shoal map assessment that also works with essential fish habitat. It's really neat, and it's going to be very useful in the future. The last one, of course, is dredging intensity and exposure calculation. This is great information to have for our dredge operators and states, especially for planning and being prepared. One of the biggest things that we deal with in the Gulf, one of our largest duties really, is to work with the states and offshore oil and gas companies to minimize conflicts of use on the OCS. There are pipelines, wells, and platforms all throughout the Gulf of Mexico, especially closer to shore, in areas that have been identified as significant sediment resource areas. BOEM reviews these applications to recommend alternatives if possible to minimize obstructions to those mineral resources needed for those restoration projects. And I'm going to show you an example of that when we get to the demonstration of the tool. The portals within MMIS are geared towards people contributing and hosting data. Some of these services are utilized by the Marine Cadastre, which is hosted by both BOEM and NOAA. There's the Mid-Atlantic Ocean Data Portal and the Northeast Ocean Data. Another unique tool feature is the ability to see where the geophysical survey track lines have been done. This area is within the Ship Shoal and was provided by LSU and the Louisiana Department of Natural Resources. This slide right here shows many of our partners, all of which are in the Gulf of Mexico. As you can see, there's a lot of opportunities for states to work with BOEM on sand and sediment needs and filling in those data gaps. We do a lot of work in the Gulf, like I mentioned, because of the fact that we do have such a high number of hurricanes that move through the area. And we have cooperative agreements right now with all the states that are going through and trying to fill in that data gaps, trying to prepare and be more proactive with trying to, just be able to protect the coast and, become more coastal resilient. I mentioned the sand study by the Corps of Engineers. The MMIS is not independent of that South Atlantic Coastal Study, sand availability and needs determination study. It's actually teaming up with the Corps to work on identifying those gaps and filling them in for future project needs. We don't want to reinvent the wheel, we just want to try to make it better. So overall, the MMIS is a capability to help BOEM and our partners in offshore mineral resource management. It facilitates proactive planning and coastal resiliency in areas often impacted by coastal storms. And as we continue to develop this software, we plan to advance and maintain the repository of the offshore mineral resources. In addition, we're committed to continuing our work with our partners to improve that meaningful data to support planning and operational needs, data discovery, accessibility, and partner usability. So if you don't mind, I want to switch on over here and show you a few things with the actual software itself, and hopefully it works. Okay. So for starters, I wanted to mention to you, this map is actually an Esri product. The base map is, to the sponsor, thank you. I'm going to begin by showing the core sample. So as you can see, there's a lot of different options. You can see the study areas here. All these blue dotted lines are polygons that have studies that have been conducted by BOEM or in cooperation with our partners in the state, as well as NOAA and the Corps of Engineers, as well as USGS have done stuff. So core samples. If you scroll in, you can click identify and click on that one link right there, and it should pop up. There we go. So as you can see, this was a core sample GA for Georgia, BOEM 2015 VC07. And it's got a lot of information in here, a lot of metadata, and actually has a link because, again, this is one of those that's been made publicly available. So if you click on that link, it'll actually bring you to the report. And this report, as you can see, shows the cores and sections, and you can see all the different layers of it. As you can see, you have sand in these areas here, along with some shells. You might find mud. In some cases, you could find peat and pieces of wood from old trees. One of the benefits of this is to be able to take some of this information. You can actually use that wood and carbon date it. I know recently, we do a lot of work, and
Brian, I'm going to interrupt.
across.
Give you your 2-minute warning. Sorry.
No worries, I can get through this quick. So a couple of things. Just seeing resources. I'm going to get out of this core samples because there's a lot of them in this area. Let's go into Ship Shoal. Ship Shoal is a very popular area for a lot of people to use sand. So I can click on sand resources, as well as go into the geological and do modeled shoals. And you can see areas where there are shoals that have been identified and things that have been done with it. Within the study areas, again, same type of thing. You can click on this and it'll actually give you links to studies that have been conducted to support it. So I'm going to take the study areas out, and I want to show you the issues that we have with our pipelines and wells. So all the hexagons are platforms. These are all wells in this area. And again, this is an area highly used for the states as a sand resource. And then you add in the pipelines. This is where our multiple use conflicts come in, that we have to make sure that we work with the oil and gas companies as well as the states to try to come up with ways to ensure that there's not going to be an obstruction. We've been very successful with it up to this point, but it's definitely something that we constantly have to work with. It's never an easy situation. A couple more things. Let me do the survey track line so you can see there's a lot of surveys that have been done in this area. As you can see, these are all survey track lines. This is publicly available information right here. And it's really neat to see all this data, when you get into it. And, last but not least, just real quick, the Lessard, we have their information. Of course, this is our partners with the state of Louisiana. And you can see here all of the data that they provided so far, all of those purple lines, it's everywhere. It's amazing what all they've been able to provide. Come over to Florida, and we also have information from them as well through Rossi. We are working with, Texas with TexSed, and with Alabama with the Oasis program. That's all I got. So I can go ahead and stop here. Again, if you have any questions, feel free to ask.
All right, Brian, thank you very much. And I want to thank all of the presenters today. So a big virtual round of applause for everybody that presented today. Thank you very much. We've got time here at the end. I'm going to make a Grant, yes. Did you have something to say, Grant?
No, just want to say thanks for the opportunity, Dave. Appreciate it. And if anybody has any specific questions, got my email address. Happy to talk.
All right. All right? So I'm going to open up the floor for the other people. If anybody's got any questions specifically for Brian and his presentation. All right, so nobody's got anything. I do. Brian, you're not off the hook yet. So when you were talking in your MMIS system, I mean, there's the source of your publicly published data. that, who is publishing most of the data that's in your MMIS system? Is it you guys, or state agencies, other NGOs, oil and gas companies? Where's that published data coming from?
Most of that most of that publicly available information is coming from, usually it's like BOEM funded or federally funded projects that, could be coming from NOAA, it could be coming from BOEM, the USGS, as well as some states.
Excellent, excellent. So is there other oil and gas companies that have published data to your MMIS system?
There actually has been some situations where companies have gone out. Main reason was because we were recommending that they would remove pipeline in an area to be able to free up some sediment for the state of Louisiana. And one of the options was, if you could go out and survey the area and let us see that it is not suitable sediment, like everybody was saying, based on our old data that we had, then we'll let you leave it in place, if that's what needs to happen. So, you're talking about millions of dollars per mile just to remove a pipeline.
Right.
And of course, they went out, they surveyed, that information became available to the public, and they were able to prove to everybody, look, what, based on the information that y'all had from 30 years ago, technology's changed. We had the new information here, and they provided it. So every now and then it does happen. We would encourage companies to do that, but
right. Well, yeah, I'm part of the old crew that remembers BOEM when it was MMS, and so you're always looking for that. The data that's contained in the archives of the oil and gas companies to make that become available for researchers, resource managers, and stuff like that. So anyway, but that's all I've got. I appreciate that. Thank you very, very much. So we're gonna Grant, I got a question for you if nobody else does. All right, so Grant, my question for you guys in Stantec. I'm getting some feedback. So if you've got your computer and your phone, I need you to mute your one of them. Speakers on your computer. So the spectral analysis that you guys are running, the requirements to process the data through your Extract tool, do you guys offer licenses for that tool that people can, the software licenses, so that they can take remotely sensed data that they might have in their, on their servers or in their possession, and use your tool to run an analysis? Or is it more along the lines that you guys run the analysis and working in conjunction with, a client per se?
Yeah, it would be the latter. We would run the software at our end. But having said that, it's a digital world. If you have data residing on a client server, we can certainly access it and run the extract tool on it. That's not a problem.
Well, I mean, you showed an amazing amount of applications that are very, very applicable to all around the Gulf, all of the teams, within GOMA. So, I mean, I appreciate you doing that, because it's, the remote sensing technology, as you allude to, has really increased multifold over the last several years. You talked about drones and working with drones to get that. I mean, just last year at the all hands meetings we had, was it last year? Time has really kind of stood still since the pandemic, and I can't remember when, but when we were in Alabama, Esri had a drone workshop at the all hands meeting, where it was, straight from the drone off of the chip on the computer and on a map and analysis. And so the technology has really, really come a long way. So again, thank you for your time and presenting that. And I would be remiss if I didn't give one more call out to Andrea and Whitney. Does anybody have any questions for those guys and their septic talk? So that's no, well, of course, I'm going to have one, at least one. So I found very interesting the statistic that you added, 9 pounds of nitrogen per person per year. That to me is, at first I was like, that can't be right. I probably, if I go to an all-you-can-eat buffet, I'm probably going to do that, in a one sitting, right? But then when I was watching your presentation and the video that you showed about, think before you flush, and really the antibiotics and the drugs that we take for whatever ending up in the water table. I know at the Research Institute in St. Pete, we've done studies on endocrine disruptors, especially down in the Keys for different marine species, and how that, people just don't. I mean, really, who thinks about the flush after they push the button, right? If they push the lever. So how can a user or a homeowner find out if they're on a septic system? I mean, I have one in my yard, but it doesn't work anymore. And the only reason why I know I've had it is because the washing machine or the washing machine dumped into it and it clogged up, and so it flooded my pool deck, right? So I had to figure out that I found out the hard way. Oh, look, there's a non-functioning, clogged up septic tank. So how do people know that they have got septics other than, maybe the grass is greener in their backyard over the septic tank?
Well, I can go ahead and take this one. I think Whitney's microphone is still muted. This is Andrea. So if you are a renter in Florida, I found out the hard way. I moved down to Florida. We rented a house. I wasn't told. I'm in the middle of Tallahassee. I thought I was connected to a sewer, and I only found out that I was on a septic system because I saw my neighbor's tank being pumped. So when you're a renter, then it's really difficult. You hope your management company or whoever rents to you lets you know, but that's a harder one. If you're a homeowner, then of course, when you do the inspection and things like that, you'll be told that you're on a septic system. And then the Department of Health here in Florida is the permitting agency. So you can call the Department of Health if you're a homeowner, or if you are a renter and are not sure, and they'll have all that information for you: size of tank, where it's likely located, etc.
Excellent. So Lee had a question for you as well. And if you saw it in the chat box, she just popped it in there. She wanted to know, what kind of traffic are you getting on your website?
Oh,
you know that.
I wish I have to find out. We have to find out for our reporting. This is a website that the communications department in Florida helped us set up, and so they are managing the traffic, so I have to reach out to them and ask, but and we have to report that soon. We have our reporting due at the end of the year. But yeah, I'm sorry, I'm not sure yet. We launched it, we worked really hard on it, and we launched it just this summer, and we're continuing to add to it. So it's really just at the very early stages. So I apologize that I don't have that number for you.
Oh, not a problem.
I'll say not as many people as we would want, I'm sure.
Well, there you
Regardless of
go.
the number.
Obviously. Well, and hopefully after today's presentation, we're going to have the video up. You'll get more traffic. I surely hope so.
Absolutely. Thank you.
Any other questions for any of our presenters? If not, we'll take it in the home stretch. Our next tool time is going to be on October 20th. And we're going to have another round of exciting talks. I think that Brian had mentioned the Shoalmate, but unfortunately that presentation by Dina Hansen is not going to be in until November. She and her crew are going to be wrapping up the tool time schedule next tool time. On the 20th, we're going to be talking about databases and decision support. So we're going to hear about the Gulf Tree, the Grid C, the Gulf of Mexico Research Initiative Information Data Cooperative, and then the Deepwater Horizon Project Tracker. So it's another exciting tool time with Dave next on the 20th. If that's all I got, and I will bid you guys a good afternoon. Thanks for coming, and hope to see you again on the 20th. Thank you very much.